Imagine a world where massive amounts of data are processed in mere seconds. This is the reality with PySpark in the realm of big data. PySpark, an interface for Apache Spark and Python, has revolutionized the way we interact with big data. It's like the brains behind a supercomputer capable of handling colossal data sets that were once thought unmanageable. Not only does PySpark grapple with large data, but it does so at breathtaking speeds. It's as if it has an inbuilt jet engine propelling it to work at lightning-fast rates. This speed is a game changer, allowing businesses and individuals to make real-time decisions based on current data. And let's not forget about its seamless integration with the Hadoop ecosystem. This means it can interact with and process data stored in Hadoop's distributed file system, adding to its power and versatility. In the realm of big data, PySpark stands as a giant, a tool that makes data processing faster, easier, and more efficient. PySpark, at its core, is a Python library for Spark programming. Let's start by breaking down this definition. PySpark is a combination of Python, one of the most popular programming languages, and Spark, a powerful open-source engine for big data processing and analytics. When these two come together, they create an interface that allows you to harness the power of Spark using Python. This is the magic of PySpark. Now let's talk about Apache Spark. It's a powerful engine designed for handling big data, capable of processing terabytes of data across a distributed system in parallel. It's built to perform complex analytics on large data sets, and it does this through something called Resilient Distributed Datasets, or RDDs. RDDs are the backbone of Spark. They are a collection of elements partitioned across the nodes of the cluster that can be processed in parallel. RDDs are resilient, meaning they can recover quickly from failures and continue processing. They're also distributed, meaning the data is spread across multiple nodes in a cluster, allowing for efficient parallel processing. Now, where does PySpark fit into all of this? PySpark is essentially a Python library that provides an interface to Spark's powerful data processing capabilities. It allows you to write Spark applications using Python without needing to know Scala or Java, the languages traditionally used for Spark programming. By using PySpark, you can leverage the simplicity and versatility of Python to handle big data. You can perform transformations and actions on RDDs using Python functions and libraries, making it easier to process and analyze large data sets. Let's not forget about the scalability of PySpark. Whether you're working with a few gigabytes of data on your local machine or petabytes of data on a distributed system, PySpark can handle it. It's designed to scale up from a single server to thousands of machines, making it a powerful tool for big data processing. So in a nutshell, PySpark is your gateway to big data analytics using Python. It combines the simplicity of Python with the power of Spark to enable large-scale data processing and analytics. The power of PySpark lies in its ability to process big data across distributed systems, all while using the simplicity and versatility of Python. To harness the power of PySpark, one must understand its building blocks. Key among these components are Spark Context, SparkConf, and RDDs. These three elements form the backbone of PySpark, each playing a critical role in processing data. Spark Context is the heart of any Spark application. Think of it as the master controller, the conduit through which all Spark functionalities are accessed. It's responsible for connecting to the Spark cluster and coordinating the execution of tasks. Essentially, without the Spark context, there would be no Spark application. Next, we have the SparkConf. This is the configuration settings for your Spark application. It allows you to set parameters such as the application name, the number of cores to use, and the amount of memory allocated for the application. In essence, SparkConf gives you the reins to tailor the environment to your specific needs. Now let's turn our attention to RDDs, or Resilient Distributed Datasets. RDDs are the fundamental data structure of Spark. They're immutable, distributed collections of objects that can be processed in parallel. What this means is that RDDs can be split across multiple nodes in a cluster, allowing for efficient data processing. They're resilient because in the event of a node failure, RDDs can be rebuilt. This makes them fault-tolerant, ensuring that no data is lost. These elements, Spark Context, SparkConf, and RDDs, work in harmony to process data. The Spark Context connects to the cluster and orchestrates the execution of tasks. The Spark conf sets the parameters for these tasks, and the RDDs hold and process the data. Together, they enable PySpark to handle big data smoothly and efficiently. These components are the gears that keep the PySpark engine running, enabling it to swiftly process large amounts of data. Theory is one thing, but seeing PySpark in action truly showcases its capabilities. Now let's dive into a few real-world examples that demonstrate how PySpark can be used in data processing. First, consider a scenario where you're working with a massive data set, perhaps in the realm of terabytes or even petabytes. The data is messy, unstructured, and requires cleaning. With PySpark, you can easily manage this task. Using its powerful data cleaning features, you can handle missing values, remove duplicates, and normalize data types across your entire data set, irrespective of its size. But PySpark isn't just for cleaning data, it's also a powerful tool for data transformation. Let's imagine you need to convert a dataset of text documents into a format suitable for machine learning. PySpark's machine learning library, or MLlib, offers a feature called TF-IDF, or Term Frequency Inverse Document Frequency. This feature transforms your text data into a format that machine learning algorithms can understand, making it easier to gain insights from your data. And of course, PySpark shines in data analysis. For instance, if you are working with a large sales dataset and want to identify trends or patterns, PySpark can help. Using its SQL capabilities, you can execute complex queries to extract meaningful insights. You could find out which products are the best sellers, identify seasonal trends, or uncover correlations between different variables. Furthermore, PySpark allows you to perform these tasks in a distributed manner, harnessing the power of multiple machines to process your data faster and more efficiently. This is a huge advantage when dealing with large datasets, where processing time can be a significant bottleneck. In each of these examples, PySpark not only makes the task possible, but also manageable and efficient. It simplifies the process of working with big data, allowing you to focus on extracting insights and creating value from your data. Through these examples, the power and flexibility of PySpark becomes clear. It's not just a tool, but a game changer in big data processing. So why use PySpark? The answer lies in its numerous advantages. First off, PySpark excels in its ability to handle large datasets. In the world of big data, where volume and velocity are key, PySpark stands out. It is designed to process data that is too large to fit into a single machine's memory. This is achieved through the magic of parallel processing, a technique that splits data across multiple nodes to be processed simultaneously. It means you can handle terabytes, even petabytes of data without breaking a sweat. But it's not just about size, it's also about speed. PySpark uses the power of Spark's in-memory processing capabilities, which makes it significantly faster than traditional disk-based processing systems. You see, when you're dealing with big data, every second counts, and PySpark can shave off precious minutes, even hours, from your data processing tasks. Moreover, PySpark is not an isolated tool, it's part of a larger ecosystem. It's fully integrated with the Hadoop ecosystem, which includes a suite of tools designed to handle big data. This means you can use PySpark alongside tools like Hadoop Distributed File System, or HDFS, and Yarn, which stands for Yet Another Resource Negotiator. This integration provides a seamless experience, making it easier to manage and process your data. Another advantage of PySpark is its compatibility with Python, one of the most popular and versatile programming languages today. The fact that PySpark is built on Python means you can leverage the wide range of Python libraries and frameworks. This opens up a world of possibilities for data analysis, machine learning, and more. One more thing, PySpark also provides a high level of abstraction. This means you can focus on the logic of your data processing tasks, rather than getting bogged down in the nitty-gritty of distributed computing. It's like having a personal assistant that takes care of the details so you can focus on the big picture. With these advantages, PySpark stands out as an essential tool in the world of big data. In the vast world of big data, PySpark shines brightly. It's a powerful tool that combines the might of Python's extensive libraries with the robustness of Apache Spark. Today, we've touched upon the basics, from understanding the concept to exploring its building blocks. We've also seen PySpark in action, demonstrating its capabilities in handling and processing large datasets efficiently. We've talked about its advantages, highlighting the ease of use, speed, and flexibility it offers. Whether you're a data scientist, an analyst, or an enthusiast, PySpark can make your big data journey smoother and more productive. It empowers you to tackle complex data challenges and extract valuable insights from massive datasets. So as we wrap up, keep in mind that learning and mastering PySpark is an investment in your future. It's a skill that can set you apart in the ever-evolving landscape of big data. Remember, in the realm of big data, PySpark isn't just a tool, it's a revolution.